If you've got access to firewood, then one of the best ways you can heat is with an outdoor wood boiler, like the one I've installed here at my place. The boiler heats water, and water is transferred to surrounding buildings by underground piping, where it's used for space heating and domestic hot water production. Now, as important as the boiler is, the underground piping itself is also crucial to the efficiency of your operation, and it's where a lot of people mess up without realizing it. Any piping option you choose needs to keep heat loss to the surrounding soil at a minimum. And that's not as easy a job as you think. There are two reasons why. All of these outdoor boilers operate at more or less the same temperature. As you can see here, it's 180 degrees Fahrenheit, or about 80 degrees Celsius, and that's the temperature of the water that's flowing through those underground pipes. So, as you can see, there's a tremendous potential for loss of energy on the way to the buildings that you're heating. Then there's the hidden issue of groundwater. Whatever pipe system you choose, it's got to remain free of water saturation during soggy times of the year, because if the insulation gets wet, it's not going to insulate anymore. This is where every homemade pipe insulation strategy that I've seen fails. Insulation gets compressed and waterlogged and offers very little resistance to the loss of heat to the surrounding soil. Durable, waterproof insulation is the reason I chose a product called Pecs for my outdoor boiler installation. It's made by a Danish company called Logstore, and I want to show you why I'm so impressed with it. The pipe is available in a number of different diameters. This piece here is left over from my own installation, and it's got an outer diameter of about 4.5 inches. That's typical for outdoor boiler installations. There are three parts to what you see here. There's the outer layer, which is tough and completely waterproof. Then there are two pipes inside. In this case, they're 1 inch inner diameter. One pipe carries the hot water from the boiler to whatever building you're heating, and the other pipe carries cooler water back from the building to the boiler for reheating. Now, the space between the pipes is filled with closed-cell polyurethane foam insulation that's completely impervious to absorbing water. So even if water does get in the outer jacket, it's not going to spread and waterlog and ruin the insulating value all along. Now, the whole assembly, foam, inner pipes, and outer pipe, is all mechanically bonded so that it expands and contracts together with changes in temperature. Because the product is flexible, the carrier pipes, the foam insulation, and the outer jacket can be continuous all the way from the boiler to the building. That means there aren't any fittings anywhere along the line that can leak. The outer jacket provides both mechanical and UV protection, and although you can't see it, in the interface between the foam insulation and the outer jacket, there's a diffusion barrier. Now, this is important because it stops the loss of the insulating gas that's part of the foam. This helps the pipe to continue providing high efficiency over its entire working life. All of this adds up to a pipe assembly that's so efficient that when 180 degree water leaves the boiler and travels the 150 feet all the way to my workshop, for instance, it only loses about a degree or two over that entire way. Now, my particular installation involved two separate runs of Pecs pipe, one from the boiler to my house and another from the boiler to my workshop. I hired a friend with a mini backhoe, and he dug trenches about 2 feet deep, connecting the buildings and the boiler. Now, only after the pipe was buried did I make the connections at both ends of each run. In my case, since both runs of pipes will be going under a driveway that I'll be installing later, I slipped them through some steel culvert to protect them from the weight of cars, trucks, and tractors. Now, the guys at Pecs told me that this wasn't necessary, that the pipe can take quite a bit of weight on its own when it's buried, but I always like multiple layers of safety, and I didn't want to take any chances with this installation. Now, even though the water table on my land isn't normally high, the rainy autumn installation schedule made the soil very soggy. There was water in the trenches, and it really showed the need for the waterproof outer layer and the impervious foam that goes into the Pecs pipe. Sooner or later, you're going to have to connect the inner PEX pipes to standard metal pipes, and special two-part fittings make this happen. There's a threaded component that fits inside the PEX pipe, and it's held in place by a tension collar that goes around the outside and bolts together. I got best results if I warmed the PEX pipe with a heat gun before buttoning up the whole connection. As you'd guess from the name, PEX Flex is flexible. It has a minimum bending radius of about 3.5 feet. And that means that you don't need elbows in most situations. Now in my case, I used strap clamps and ropes to bend and hold the pipes in position while I backfilled around it. Now in this case, as you can see, the pipes come up to the concrete pad before the furnace is in place. I left a notch out of the back of the concrete pad to make it easy for those pipes to be positioned just right before setting the furnace down in place. Now, PEX Flex pipe is not cheap, and that's the thing that throws a lot of people off. But compared with anything else I looked at, I figure PEX Flex will more than make up for the cost through increased efficiency and reliability for the many years I intend to operate my outdoor furnace.